Hi, I'm Beth from My Tutoring Bee, and today we are going to be talking about two-step equations, how to solve them, some tips and tricks that might make it a little bit easier for you, and we're going to do a lot of examples, so let's get started. Okay, let's get into some problems here so that we can start practicing. So let's take a look at this first equation, 3x plus 9 equals 12. So what we want to do is first identify where our variable is and what's happening to it. So here's x right here, and I see a 3 that's being multiplied times that x, and then I also see a 9 that's being added to that 3x term. Now the equal sign, the equals 12, that's over on the other side of the equation, so we're not too worried about that right now. We just want to kind of identify what it is that we're looking for and what we want to do. We all know PEMDAS, order of operations, but we want to think backwards PEMDAS. We are trying to undo all of these operations that are happening to this variable. So in order to undo them in the correct order, we need to start at the end and work our way backwards. So that means any addition and subtraction that we see, we want to undo that first, and then we're going to move to any multiplication or division. Now in the problems that we're doing today in this video, we don't have any parentheses or exponents. Okay, so addition and subtraction. We do see that 9 is being added to the x term. So we want to undo that addition first. And a lot of students like to draw a line down through the equal sign, and that gives us a really good visual of right side and left side. Because whenever we are doing an operation in order to undo something, we want to make sure to do it to both sides of the equation. So plus 9, the opposite of addition, is subtraction, and we want to subtract that exact number because we want this term to cancel out and equal nothing. We want it to equal 0. So let's go ahead and subtract 9 on this side as well. So these 9s are going to cancel out here, and so what are we left with? Well, we've got this 3x term, and then 12 minus 9 gives us 3. Okay, so now we are going to, again, just kind of look at our equation, assess the situation. X is being multiplied times 3, so we want to undo that multiplication, and the opposite of multiplication is division, and we're going to divide by that number in order to get 1x. When we're adding and subtracting, like we did up here, we want the result to be 0. When we're multiplying or dividing in order to get rid of something, we want that result to be 1. Okay, so we want 1x left here. So we are going to divide by 3. And I am writing it like a fraction because a fraction is just division, right? So that helps me to show my work underneath and just easily be able to cross this 3 out. So these 3's will cancel out here. So that leaves just x. Now, don't make the mistake. I see a lot of students doing this when they're first learning how to do this skill. Don't make the mistake of dividing by 3x. We don't want the x to cancel out, right? If I divided by 3x, then this x would cancel out as well. And then I would just be left with 1 here. And that's not exactly what we're going for. What we want is 1x, or just x, because whenever we have a coefficient of 1, you can write 1x, but we usually don't write it that way. All right, and then we're going to divide over here. 3 divided by 3 is 1. So we get x equals 1. Now, just some formatting things that I want you to notice. Whenever we are solving, we are now starting to work from top to bottom rather than left to right. So when you're solving equations like this, your equations should sort of follow this funnel shape, this V shape, right? Something else to note is that we started off with an equation, and then the next line or the next row, we showed the operation that we needed to perform in order to undo something in that equation. And then once we performed that operation, we wrote a new equation. And then underneath that, we showed another operation in order to undo that multiplication in this case, right? And then once we solved that operation and completed that operation, we wrote a new equation. So when you are formatting your work, it should follow this sort of layered format where you have equation, operation, equation, operation. And that's how you're showing your work and then also writing your new equations so that you can see what new work you need to do to continue solving. All right, we really took it step by step on that first one. Let's take a look at another one that is very similar and see if we can work through this. And I do encourage you to pause the video on these, try these out on your own, and then resume and see if you got it right. Here is our variable y. It's being multiplied by a -2, and then 15 is being added to that y term. So what do we need to do? We need to undo any addition or subtraction first. So that means we're going to start with this 15. We're going to subtract since that's the opposite of addition, and we want it to equal 0, so we're going to subtract 15. We need to do that to the other side as well. So those 15s are going to cancel out. Let's see what we're left with. We've got a -2y equals, and then 37 minus 15 gives us 22. Okay, great. Now, again, let's take a look. Where's our variable? What's happening to it? It's being multiplied by a -2. So the opposite of multiplication is division. We could just divide by 2, but if we only divide by a +2, then just the 2's are going to cancel out, and that negative is going to be left there, and we're going to be left with a -y. And what we want for our final solution, we want just a +1y. So what we can do here, instead of just dividing by 2, is we can divide by a -2, because these negatives are going to cancel out, right? Whenever we're dividing negative by negative, that results in a positive. So we're going to divide by -2 over here as well. So this -2 cancels out, leaves us with just y, and then 22 divided by -2, positive divided by a negative gives us a -11. All right, let's take a look at another one. This one is pretty similar. The only real big difference here is now we have something that's being subtracted. So here is our variable m. M is being multiplied times 5, and then that whole term we're subtracting 8 from. So just like we did in these last two, we had addition in the last two that we needed to undo, but in this time we have subtraction that we need to undo first. So in order to undo that -8 or -8, we're going to add 8. Remember, because our goal is to get anything that's being added or subtracted to the term that has the variable, we want that to equal 0. So we're going to add 8 to both sides of the equation. That's going to cancel out and give us 0. We don't need to write the 0. We're just canceling it out because we want it kind of out of the way. We're going to drop down our 5m. That's all that's left. And then let's see, 27 plus 8, that gives us 35. All right. Now we've got 5 that's being multiplied times n. So we need to undo that multiplication by dividing. We're going to divide both sides. 5's are going to cancel out, leaving us with just m. 35 divided by 5 is 7. All right, there we go. Also, if you want to check your answer, in fact, I encourage you to check your answer. In order to check your answer, all you have to do is take your solution and substitute it back into the original equation and use order of operations to solve and see if what you have on both sides of the equal sign is actually equal. Let's do that with this problem. So we started with 5m minus 8 equals 27. And we discovered that m equals 7. So I'm going to go ahead and substitute that 7 in for m. And then let's solve and see if it does work out. So order of operations tells us to do multiplication first. So we're going to multiply 5 times 7. That gives us 35. Okay, and now the last operation that we have left is 35 minus 8. So that is 27. So we can see that we wound up with 27 on both sides of the equal sign. So that tells us that we found the correct solution for m. All right, let's move on to this last problem here on this page. We have negative c minus 12 equals 36. All right, let's go ahead and draw our line down through our equal sign. Here is our variable. We've got a negative out in front of it, and then 12 is being subtracted from it. So we know that we need to undo that subtraction first, and we are going to add because that is the opposite. Okay, so that cancels those out, and so we're left with negative c equals, and then 36 plus 12 gives us 48. All right, so this negative c, let's think about what that is. It is really a negative 1c, right? We just normally don't write the 1 in front of the variable when it's a 1 coefficient, whether that 1 is negative or positive. So we can think about that operation to undo that negative as dividing by negative 1, right? Because that is essentially what the coefficient is. You could also multiply by negative 1. That would also accomplish the same goal of getting us to a positive 1c. But this is typically the way that you'll see it as division of negative 1. So that negative 1 and that negative 1 are going to cancel out, leaving us with just c. And then 48 divided by negative 1, that just gives us negative 48. Let's get into a little bit more complex problems. You'll see fractions in these problems. I don't want you to panic. We know how to work with fractions. We know how to add, subtract, multiply, and divide them. And we also know that fractions are just a different way of writing a division problem, right? So don't panic here. Let's take a look at this first one. We've got x over 3 plus 7 equals 28. All right, so here's our PEMDAS. Here's our reminder again. We're working backwards, so that means we're going to take care of any addition, subtraction first, and then move on to multiplication and division. So like I said, that those fractions are just division problems, right? This means x divided by 3. And then we've got 7 being added to that x term, and then that equals 28. So let's go ahead and draw our line down through the middle. And we know that we're going to undo any addition subtraction first. So let's undo that addition of 7 by subtracting 7. All right, those are going to cancel out there, leaving us with x over 3 equals, and then 28 divided by negative 7. So positive divided by a negative, that's automatically going to give us a negative. And then 28 divided by 7 is 4. All right, so let's see here. Now we have that x divided by 3, right? So we are going to multiply. Multiply is the opposite of divide. So we're going to multiply by 3 and multiply by 3. Now, be very careful here because a lot of times when students are first learning this skill, they see that 3 times and then they see another 3 and they think, oh, this equals x over 9, right? But that's not actually what we're doing. Remember your rules for multiplying fractions. This 3 is a whole number. So what do we do when we're multiplying a whole number times a fraction? We put that whole number over 1. And now you can see that this 3 is in the numerator and this 3 is in the denominator. And we can cross cancel them, which is our whole point, right? That's why we chose to multiply by 3, is to get rid of that 3 that's underneath the x, right? That's the whole goal here, is to get x by itself. So this 3 will cancel out with this 3. You can write the 1 and 1, and let's think about what that looks like. So if we have 1 times x, that just gives us x. And if we have 1 times 1, that just gives us 1. And anything over 1 is just that number that's in the numerator, right? So this will give us just the x that we're looking for. Over here on this side, we've got a negative 4 times 3. And so 4 times 3 is 12. A negative times a positive, that gives us a negative. So we wind up with x equals negative 12. Now with multiplication, I do want to point out here, this is the one time that you'll see the operation sort of written out to the side of the equation as you're trying to solve rather than underneath. And that's just because of the format of the fraction. It just is a little bit easier for our brains to see how these fractions can cancel out when we write them next to each other, when we write that whole number and make it into a fraction next to the fraction that we're trying to cancel. So, so the formatting is a little bit different on this one, but as you can see, we're still just following the same steps here. All right, let's go on to this problem here. We have b over 5 minus 14 equals 6. All right, so we know that b is being divided by 5 and then 14 is being subtracted from that term. So let's go ahead and undo that subtraction first, and then we'll talk about that division. We're going to add. 14, right? Opposite of subtracting 14 is adding 14. Don't forget to add that over here on this side. These 14s are going to cancel out. And we are left with b over 5 equals, and then 6 plus 14 is 20. All right. Now we need to undo that division of 5, right? We're trying to get this b by itself, so we're going to multiply by 5 on both sides of the equation. If you want to write it as a fraction, go for it. That's totally fine. But we can see that this 5 and this 5 are going to cancel out and leave us with just b over 1 or just b. So b equals, and then 20 times 5, that gives us 100. And again, I encourage you to pause this video, work on these problems, come back and see if you got them right. I also encourage you to use our solutions, substitute them back into the original problems, and check your work and make sure that we are solving them correctly. All right, let's take a look at this one. Now this one, we have the variable is now over on the right hand side of the equal sign. Here's our equal sign here, and the variable and everything else is over here on the right. And that's okay. An equal sign just means that the left side is equal to the right side. So we are really not doing anything too different here. We've just sort of switched these around, but the process is all still the same. We still need to identify where our variable is. We've got w right here. And what's happening to it? It's being divided by 4, and we are subtracting 2 from that w term. So the rules are still the same. We're going to get rid of that addition or subtraction first. So let's undo that subtraction of 2 by adding 2. So that means these are going to cancel out over here, leaving us with w over 4 equals, and then 8 plus 2 is 10. You can even solve or simplify the right-hand side before you solve or simplify the left-hand side. Doesn't matter which side you do first. All right, let's see here now. W is being divided by 4, so we're going to multiply to undo that division. Multiply over here. This 4 cancels out with this 4, leaving us with just W. And then 4 times 10 is 40. All right, last one on this page, and then we do have a few more examples. We've got 18 equals k over 9 plus 13. All right, we're going to undo that addition of 13. Remember both sides of the equation. That's going to cancel out that 13 and leave us with just k over 9 equals, and then 18 minus 13, that gives us 5. Okay. Now we've got k is being divided by 9, so we're going to undo that division by multiplying. And again, you can put that over 1, make it a fraction if you need to. Those 9s will cancel out, leaving us with just k over 1, or k. And then 9 times 5 is 45. All right, here are a few more problems. These are the last examples that I have for you in this video. Give these a try on your own, and then resume the video and see how you did. Okay, so hopefully you've done that. I'm going to go through these pretty quickly. Let's go ahead and start with this first one. We're subtracting 5 from both sides of the equation. That's going to cancel that out here, leaving us with just 6x equals 47 minus 5 gives us 42. And then 6 is being multiplied here, so we need to divide by 6 on both sides. That's going to cancel out the 6 there and leave us with 7. All right, on this next problem, we've got 28 equals 7 minus 3y. Here's our variable. Now, hopefully this didn't trick you too much, but this 7 is positive, so in order to get rid of it or make it equal 0, we are actually going to have to subtract 7. I know a lot of times students will see this subtraction sign and think the opposite and think add, but this subtraction sign belongs to the 3y, and when there's no sign out in front of a number, then we know that that number is positive. So in order to undo that, we are going to subtract 7 from both sides. So hopefully that didn't trick you too much. That's going to cancel that out there. 28 minus 7 is 21. And then that negative, like I said, it does go with that 3y. Whatever signs you see, it goes with the term that it is in front of. And then we're going to divide by negative 3 in order to cancel out both the negative and the 3 at the same time. So y equals negative 7. Ooh, squeezing in the answer there. Okay, let's go on to this one. We've got negative 2 equals 6 plus z over 2. So z is being divided by 2 and 6 is being added to it. And that 6 is positive. So in order to undo that positive 6, we're going to subtract 6. Subtract 6. That's going to cancel that out here, leaving us with just a positive z over 2. And then negative 2 minus 6 gives us negative 8. I do have a video on adding and subtracting positive and negative numbers and like some little tricks that might be helpful for you when you're first learning how to do these. It can be a little bit tricky. All right, so then we've got z over 2, so we're going to multiply by 2, multiply by 2. That's going to cancel these 2's out, and that's going to leave us with z equals, and then 2 times negative 8 gives us negative 16. So negative 16 equals z. All right, last one here. We've got negative v over 3 plus 4 equals 13. We're going to undo that addition first by subtracting 4. That's going to cancel that out. And then we're left with negative v over 3 equals, let's see, this would give us 9. And then for this one, that negative and 3 can be canceled out at the same time by multiplying by negative 3, right? Because if we think about this negative and this negative will cancel out, the 3 and the 3 will cancel out, leaving us with just v. And then we don't want to forget to multiply by negative 3 over here as well. So that leaves us with v equals negative 27. Okay, so how'd you do? Let me know if you like this video. Please subscribe. That really helps me to continue making these math videos for you. And let me know about your thoughts in the comments. Thanks so much.